Hey guys, what's up? I'm Sampath Niroshan. Welcome to Arduino Lesson 1. Now, why do you think about Arduino? Maybe you're an electronic enthusiast, or maybe you're kind of thinking about really getting inside this electronic jargon, and why this Arduino thing is exactly your choice. Now, let's say you're kind of a person that you don't know anything about electronics, or you don't know anything about this computer programming, and you may have kind of got fantasized with things like in the movies there where people kind of work with new robotic kids in a keyboard, they're kind of playing da 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 da. So those things might be fantasize you to get into this thing, but still you have some problem. What is that? Where to learn this Arduino exactly? Because most of people are kind of teaching this, but they are kind of okay for intermediate level or something higher from that. But still, if you're kind of raw beginner, this thing is not gonna work out. I have kind of seen many videos and still they're not working out. So I was thinking, why shouldn't I go from the beginning? Why shouldn't I kind of teach for a guy who has no knowledge at all in electronics or no knowledge at all in computer programming? So if you're looking for that kind of a solution, this is the video. Hit subscribe button, like the video, and stay tuned. Now, if you're learning Arduino, what are the basic things you need? Now, first of all, I have to say that you need some basic knowledge in electronics. If you don't know how to manipulate them, then this journey should be pretty hard for you. Don't worry, I got your back there. I'm starting from the basic, smallest, tiny electronic equipment. Electronic equipment. So you can start from there and you can start learning electronics along with Arduino with me. And next thing you need is programming. You should know a bit of programming, how the computer works, how the computer program works, how it gets compiled, and how it's actually transferred into a microcontroller, and how to get the things done. When you need to gain control over this Arduino piece, you should have some knowledge in programming as well. And don't worry there as well, I got you covered. Yeah, so let's get into the basics. Now, what is the first thing you need to know in Arduino? That's exactly the board, because Arduino is kind of a simplified programming console where you have a small microcontroller and some small memory plus some input output things. So it pretty much kind of covers a whole computer. So what you're talking about is a small tiny piece of computer which can do some powerful things which fits inside your pocket. So as the first thing, let's try to learn what is the Arduino board and what are the components in that Arduino board and what can we actually do with that Arduino board. Let's get into it. An Arduino board looks like this. Now this is one assembled board. Let me give you guys a closer look. So this is how it looks. In the close, this is the front side and this is the back side. In this Arduino board you can see several components. We'll get into that later. Let me show you guys how an original Arduino board looks. Now I purchased an original Arduino board from a local store. I already opened it. So this is the Arduino board I kind of got from the local store for like 1,300 rupees. So it's not that expensive. If you say about this assembled board, it's cheaper than this, by the way. So you can buy one for like 900 rupees, by the way. So this thing is like 1,300, 1,400 rupees. And what's coming with this thing? Now you are getting this kind of power cable. This power cable is a USB cable where you can kind of connect this with your computer to upload sketches, which is how the programs are called. and you can see a printer port right here, and you can see a USB cable right here. So this thing fits with the Arduino board. In this port you can simply connect it. In the original Arduino board, I'll give you a closer look. This is how it looks. You can see you have this UNO and Arduino, this emblem, they are printed, and you can see some made in Italy, this thing is printed, and in the back side it says many information, like it says the logo again, Arduino board model UNO R3, open source electronic platform, Arduino CC, that's original company, plus it's made in Italy, that's where this Arduino project was first launched. So you can see that this thing is kind of an original board than the assembled one. You can see the difference when they are closer. See the front side and see the back side. So which one should you buy? It doesn't matter, like if you kind of buy this assembled board, only thing is when you upload sketches using the computer software, you need to kind of define the port and the model yourself. So there is an extra effort there. If you're talking about this original board, as soon as you connect, the software is simply kind of understanding what the board is, and it's simply detecting the port and the board, so you don't have to select yourself. And what else you're getting? You're getting these things. These things are called as header pins. You have many uses out of header pins. Let me give you guys a closer look. So these header pins are used to simply connect this board into breadboards. So as you can see, in the usual board you don't have any header pin ports to be soldered. I didn't get this thing with the original board. I got this with the local board, the assembled one. There you have these kind of holes where you can kind of solder these header pins, and you can work with the breadboard without much problem with the assembled board. But I don't know why in the original board you don't have that capability. With this you're not getting header pins, you're getting only this and this power cable right here. That's all you're getting. You're not getting header pins. But with the assembled board you're getting this one, plus you're getting this power cord, plus you're getting header pins. So with the header pins you can kind of simply connect it with the breadboard. That's super cool with the assembled board and the original board. So what are the components in this Arduino board? Let's have a closer look and let's see what's inside it. It's worth knowing it, believe me, otherwise it will be a heck of hard work for you guys. And you can see that this thing is coming with these plastic female type ports, and each of these are pins. We are calling them pins, and these plastic pins are used to connect several things like equipments straight away, or maybe jumper connectors where you can kind of connect them in a breadboard, and you can kind of connect some other equipments like sensors or whatever. So if you give a closer look to these pins right here, you can see that it is printed with some numbers 0 to 13, and it says digital PWM. PWM printed right here stands for pulse width modulation, which means you can use these pins in this scale as digital pins. Digital means, in computer terms, it simply kind of says digital means you have two values like 0 to 5 volts. But if you say something like analog, you have values in a range, like in between 0 and 5 anything is possible. Like if you say 2, if you say 3, if you say 0.2, whatever you're saying is counted with analog values. Right here with this digital PWM, you can kind of use them as pulse width modulation pin, which means you can kind of use it as analog functions as well. But usually we are using them for digital. But you have this TX and RX. TX means transmit, RX means receive. You can see the same letters right here, TX and RX. So they are LEDs indicating whenever the board transmits things, the TX lights up, and whenever board receives signals, the RX is lighting up. And you can really use them to kind of debug your programs whenever you have problem. So to simply see the functionality of the board, TX and RX is really important. And right here, TX and RX means you can kind of use TX to kind of transmit pulses, transmit digital data usually with the first pin, and RX is to receive. So usually when we make programs, we keep 0 and 1 left, and we are starting by 2 to upwards up to 13. And you have a GND simply means that's ground. So ground means you can kind of connect, you can think of this as 0 voltage or minus voltage. So when you kind of connect things, simply ground is where your minus or the 0 volt terminal is going. And this is not the only place you have ground. You have right here another 2 pins with ground. We are coming there later. And you have port right here. This is very important, right? This one is a printer port, the classic printer port available in a computer, and this thing is what connecting your computer through the cables, this port to your computer, and you can kind of use it as a power up port. So simply the circuit is getting power with this port, and same time this thing is kind of getting the program feed. So whenever you kind of upload a program, we are calling a program as a sketch, and those sketches are kind of uploaded to this board using this port. So this is very important. And right here you see a small button. This button is the reset button. So whenever you press, this board is restarting again. That's what happens with this button. Whenever you press this, the board is kind of resetting its settings, and it's kind of restarting the whole process again with this reset button. It's very useful, by the way. And you have this pin set. This is also something to have a look at. So as you can see, it says analog in and power. There are 2 sections. Analog in means you can kind of give analog inputs. I already told you that analog has various values in a range, like from 0 to 5, anything goes here. So this A0 to A5 can be used to kind of give those datas inside this thing. So let's say if I simplify this, in an LED, if you talk about digital, it either turns off and keeps on with the maximum brightness. But if you talk about analog signals given to an LED, simply the LED can kind of fade off, fade on, fade off, fade on, because it's receiving the different voltages in a range. So I think you pretty much got the idea. So I am kind of having closer look right here. So I can see that it simply says here the power, and you have several openings right here. This one says V in. Now this thing is very important, because V in means you can kind of give voltage to this board in a range starting from like 6 volts. That would be the minimum, but even with 3.7 volts this thing works. I have tried. So this thing starts like 4 volts upwards, but the maximum you can give using any power source to this board is 12 volts, because I mean in the books it is printed 20 volts, but if you try 20 volts, definitely you're burning this board, and more than 20 volts, no way, man. So this port, or this port, this is the power port. So you can simply kind of use it as an external power port using a 9 volt battery or whatever. You can kind of simply feed power to the circuit, and you can use a small jack which is kind of fitting in this, and you can kind of connect it into a power supply, any kind of a power supply, and simply it works with that. So the minimum you can give is like 6 volts, and the maximum you can give like 20 volts. So but 12 volts will be the ideal maximum. Guess what, I have kind of tried that, and 12 volts, more than 12 volts, it's not going to kind of treat your board that cool. So next thing is ground. Simply I emphasize that again. Here 5 volts, so you can kind of simply give 5 volts to any device you want, and here 3.3 volts for lower voltage devices. This thing right here, this is the main IC, by the way. So I am giving a small closer look, and it says Atmel. Atmel is the company which manufactures this IC, and the IC name, I think it's visible to you guys, it says Atmega 328P. So this is the name of this IC. Knowing this company plus this IC type is very useful, so you can kind of find out the data sheet and have a full understanding about this thing. And if I go back to my assembled board right here, right, it has a different IC. I don't know if you guys can read this, but it is also from Atmel, and this one says Mega 328, right? So this has that Mega 328. So this is a type of IC, and the same IC but with a different interface you have right here. So this is the assembled version, but here in the original version this is what you have, and it says the company as Atmel and Atmega 328. That is the main IC. This is the microcontroller, by the way, and this is the brain for your entire settlement. So it kind of takes all the CPU functions like controlling things, processing things, analyzing things, blah blah blah. Those things are happening with this IC. This is the main part. This is the most important part. Learning about this is really important. So let's get into that later. And what else we have in this board? One important thing is this guy right here. I'm going to give a closer look. So observe this. So right here what we have is the voltage regulator. So this voltage regulator is simply kind of regulating the power coming from these ports, and if it is kind of overload, this is kind of not letting the extra amount to kind of flow through the circuit. It's kind of simply regulating the thing, as the name, that's what it does. But you know what, it has its own limitations, so don't try pushing it too hard because it's going to simply burn your board. So those are the things you need to know about this board, and from next program onwards we are going to learn how to make circuits with this board and how to kind of see if your board is really functioning. That's pretty easy. You take your code right here and get the printer port, and as you can see this fits the shape. So right, see the shape and kind of connect them together. When you hear the tick, heard it, right? The tick, it means it's connected. So next thing you need is a power source. Right now I'm going to use this as my power source. This power source is a power bank, by the way. The total output is like 3.7 volts. So I'm going to kind of connect this to the USB outlet. So I can see the board turns on, and you can see the power LED. I'm going to get a closer look like here. See, the power LED says this thing is receiving power and it's on, and you can see this L thing says it has some functions working on, and you can see TX and RX is turned off because I haven't uploaded any kind of programs to this thing. So it's simply turned off because it's not transmitting any signals and it's not receiving any signals. So you can see the board is actually functioning. And if you kind of try the same thing, I can kind of try the reset button. See, the thing restarts again. See, whenever I kind of push that button, see, the things are happening from the beginning again. Now if I try the assembled board, let's see how it looks, right? So I'm going to kind of unplug this board, boom, and I'm getting my assembled board right here, and I'm going to simply kind of give power, and you can see it turns on. Now this thing already has some sketch I already gave to this board for my LCD circuit. So it simply kind of says the power is on and the lamp is on, but it's not transmitting any signals from this to this circuit or out from this circuit. So I don't see any TX or RX working right here, right? So you can see the TX and RX when you give a closer look right here. but they are not functioning. Reason, I have never kind of given any kind of input and output to this. It simply has a program, but it's not yet functioning. So it also has this reset button. Whenever I kind of hit that, see, the lamp is kind of turning off, and then it starts the work again. So that's pretty much for today, and from next video onwards we are going to use these boards, both of these boards, and we are going to kind of simply get power out from this circuit, and we are going to feed that power into some sort of a working circuit, and let's see the different ways of getting power out from this circuit. So I am going to kind of give you the things you need to kind of get those works on. Okay guys, for the next video we are kind of needing some small things. Let me show you. Now first thing you need is a small LED, this one with 2 pins, and you can choose any color you want, not the RGB, because it's not going to work out right here. We are kind of dealing with it later, and it has 3 pins. So what I need is the 2-pin LED with any color you want. That's the first thing you need. The second thing you need is a small resistor, somewhere like 220 ohms would do the work, and this is called a resistor. You need that kind of one. And next thing you need is again a resistor, but this one is a bit more resistance. So what I need is 1k ohm, 1 kilo ohm resistor. It looks like this. You need to grab one yourself as the next thing. Next thing you want is a small switch. This thing is called as a push button. See, push, 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 push. So this thing you can push and you can kind of do some work, which has 4 pins. You can have different colors, but still the concept is same. I need this little tiny push button, one of that. And the next thing you need is jumper connector. So these things are called as jumper connectors, where there is a small cord and there are probes in the sides where you can kind of fix this in a breadboard, and you can kind of demonstrate some serious circuits. So this is not that expensive. I bought them for like 10 rupees each. So in dollars it might be like $0.01 or something. So you can go to Amazon or whatever, and you can kind of simply buy, and from a local store easily you can buy these things, and they are not expensive. Guess what? This is not expensive, right? In Sri Lanka, one of this is like 10 rupees. That's the price I'm buying. Next thing you need is a breadboard. This thing is called as the breadboard. This is the super tiny version of that, and you have some holes where you have series of holes, and they are kind of connected in fancy ways. Don't worry about that. I'm going to teach you guys. And this is the smaller version. By the way, this thing right here is the bigger version. I already worked with a small circuit in the intro, where an LCD thing, printing everything. That's simply fantastic, right? So this is that board I'm working out, and this is the bigger version, by the way. So you can hook up things where you can connect things with some jumper connectors, and you can connect these things into your board, so you can kind of get the things done without any fancy works like soldering, putting things in PCB, using the bout, blah 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 blah. I mean, who is kind of working with bout nowadays to demonstrate circuits? Seriously, you just buy a breadboard. This is the bigger version. You have even bigger ones, and this is the smaller version. I suggest this one. I like the size, plus it's very cheap, right? This one I bought for like 350 rupees or something from a local store, but in Amazon or AliExpress or something like that, you can buy this for like $1.8 or something. So this thing fits for now, and I prefer you buy something like this. But if you want to buy something bigger, if you like big things, so go for this. This is no big difference from this one. I mean, the price will be like little up, something like 100 rupees extra. So I bought this for like 475 rupees or something. So in AliExpress or Amazon or eBay or something, you can buy this for like $2. Within $2 you can buy this. So it's not expensive. And the final thing you need is, as usual, the UNO board, right? The Arduino board with the power cord, the relevant power cord. So those are the things you need for next video. What are the things? Again, I'm going. You need an LED. you need 220 ohm resistor, you need 1k ohm resistor, you need a power switch, you need jumper connectors, and you need a breadboard, plus you need an Arduino board with the power connector, and that's all you need. We'll meet in the next video, and don't forget to subscribe, and don't forget to kind of like this, comment this, and share this among friends so you can kind of spread out the knowledge and kind of say somebody else to kind of learn as you do from the raw beginning. Believe me, raw beginning. Okay, so that's it for today. Goodbye friends, and let's meet in next video very soon. Yeah, very soon. Bye.